Hi, welcome back to AP Physics C Mechanics, Unit 4. Here talking about linear momentum. So in the last video, we talked about center of mass, which is something that's very important because moving forward, sometimes the equation or the question will ask you for, what happens to the center of mass. So now in this video, what we're going to focus on are the two concepts that we know as momentum and impulse, okay? And then in the next video, kind of talking about the progression, we're going to combine them into a single theorem in the next video. So algebra-based physics, again, the definition of momentum is the product of an object's mass and its velocity. So one way to think about it is a simple definition is that it's inertia and motion. So when an object's mass begins to move, right, now it has momentum. Mathematically, momentum is calculated as P equals m times v, all right, or mass times velocity. Now, something you notice, we drew our little half arrow signature there, and that tells us that momentum is a vector quantity. Now, when you're just looking at the concept of momentum, it's not a big deal if you forget the sign. But when you get into conservation momentum, which will be the last video in this unit, there you would have to account for it, because especially if two objects are coming and colliding with each other, one of these momenta has to be zero, or it's not zero, excuse me, it has to be negative. Okay, because one's coming from the positive direction, one's coming from the negative direction. So the total momentum is going to effectively subtract out at that point. Now, when we talk about an object's velocity changing, so if it were to change, that means its momentum is going to change, which means if we change the velocity, we accelerate the object, right? Which means there's a force that's involved. So this statement implies that there is going to be a link between momentum and force. That link starts to begin with this idea of impulse. So the product of a force and a time interval over which that force acts is what we call impulse. Now, just like we've been doing throughout this, course, I'm going to distinguish between average and instantaneous, right? So average is something that you would have done in an algebra-based course. Now, instantaneous is something we do now here in a calculus-based course. So the average impulse is simply the average force times the time interval. Okay, so again, this is more of our algebra-based look of it. Now, when we talk about impulse, right, we can just think of it as it's an instantaneous impulse. And so the instantaneous impulse is the integral of f dt. Okay, and so you can see anytime you have the integral, it's an area, right? And so that's why we have up here this cool little graph. This graph is actually what happens to the head during a car accident or a car crash of a 2009 Dodge Grand Caravan, okay? So impulse is the area of a force time graph. Okay, so what's happening is if I find the area of this segment, right, I am finding the impulse of that segment. Okay, now NHTSA, the National Highway Traffic Safety Authority, they have computers to do this, but a fun activity where if you were to get some crash test data and just simply make triangles or rectangles or trapezoids fitting into that area, you can figure out the impulse that was given. Okay, but you can also find the average force on the object, right? So the average force is equal to the impulse over the time, right? So what happens is, because the actual graph is an acceleration time graph, but we can make it a force time graph. But what happens is if I look from this interval to this interval and I find how much force was exerted over that interval, what I just drew here in blue would be equal to that spike. Okay, and that's more interpretive when you talk about like an algebra-based course, right? But it also gives us an idea of like how much force was acting over that time interval versus having to hope that I can find that data somewhere in a crash test. Okay, So your average force is going to be the impulse divided by that time interval. So now I'm just thinking, instead of making it a rectangle, or excuse me, a triangle, now I'm turning it into a simple rectangle. Okay, but let's look at, sorry, I may have accidentally closed this. All right, so let's go through this, try to get to our point where we're going to go to the example problem. Okay, so now let's take a look at an example problem. So this has, it may look like you have a little bit of calculus, but it's not going to be too bad. All right, so what is the momentum as a function of time of 5 kilogram particle moving with a velocity given by this function? V of t is equal to 2.0 I hat plus 4.0 t j hat meters per second. And then what is the force acting on this particle? Okay, so we have two parts to this, right? So we're going to find the momentum first, right? So P is equal to mv, okay? So all I have to do here is do 5 times my vector and that'll give me the impulse, right, on this, the momentum of this object. So 5 times 2 I hat is going to be 10 I hat. And then 5 times 4t is going to be 20t j hat. So what that's saying is I'm being impacted, right, in some way of a momentum that's equal to 10 kilograms times meters per second plus 20t kilograms times meters per second. Okay. So this right here is my momentum, right? So 10 I hat plus 20t j hat kilograms times meters per second. The second part of the question says, what is the net force acting on the particle? Well, if I want to find net force, I need to do m times a. But my a will come from, not my momentum, sorry, but from my velocity, right? So a is dv dt. So I'm going to take the derivative of my function, or of my vector, so 20 I hat plus 4.0 t j hat, and find that my acceleration is simply going to be 4.0 j hat, right? Because if I take the derivative of 2 I hat, it's 0 because 2 is a constant. And so the only thing I'm taking the derivative of is really that 4.0 t, okay? So now I can find the net force. So I do 5 times my acceleration, but I'll write in the 0 I hat. Okay, so it's 5 times 0. So I have no force in the x direction. And then I have 20 newtons of force, right, in the y direction. So that would be the net force that is acting on this object. Okay. So here in this video, we focused on the two separate concepts. And you could also maybe turn this into, if you knew how long this took, right, you can figure out the impulse, because now I have force. All I have to find is the time, or the dt, right, or the delta t. And then I can find how much impulse is given to it. So in this video, we focus on the two concepts separate. Now in the next video, we're going to focus on them together.